In this question, you have to write the formula based on the IUPAC name. So IUPAC name is given tetraamine di aqua cobalt 3 chloride. So we know that in such cases, the cationic part will be written first. So cationic part is here, this one. This is complex and this is primary valence, chloride. So here we have cobalt 3. So you will write CO and then you have tetraamine. So it will be NH3 whole 4 and diaqua means H2O, you have only 2. And then you have chloride. For that you need to identify it is here 3 oxidation state. And ammonia and water molecules are neutral molecules. It means whatever oxidation state we have on cobalt, the same will be charged on this coordination sphere. It means there should be 3 chlorides to balance this plus 3. So here you will have Cl3. CO, NH3 whole 4, H2O whole twice, Cl3. Next one, potassium tetracyanidoniculate 2. Now there is a hint here. Because it is 8, it means the coordination entity is anion. If you have 8 suffixed with the metal, central metal atom, it means the complex part is anion. So it means this part, tetracyanidoniculate, is anion and this potassium will be outside. So potassium we will write afterwards. First we will identify how much charge will be there on this coordination entity. Based on that we will decide how many potassiums will be there. So first the coordination entity, which is anion. So it will be tetracyanidoniculate means Ni and cyanido Cn whole 4. Now it is given nickel is in +2 oxidation state and we know that cyanide has -1 oxidation state. It means total here will be +2 minus 4 equals to -2. So 2 minus charge will be there. For balancing the -2 charge, we should have 2 K plus here. So we will say K2. So the formula will be K2NiCN4, where NiCN4 is anionic part. That's why 8 was there. 8 suffixed with nickel. K2NiCN4. Next, tris ethane 1,2-diamine, chromium 3 chloride. So again, it is easy. Chloride is the anionic part. It means the coordination entity is cationic. And here we will write tris. Tris is written when we have already the numbering, and it is polyatomic ligand having numbering. So we have it in parenthesis, and because it has numbering already, we have tris here. We won't write tri here. We will write tris here. So that's why tris. It means there are 3 ethane 1,2-diamine with chromium 3. So it will be Cr chromium, and you have En whole thrice. Tris. This chromium has oxidation state 3 and ethane 1,2-diamine is neutral. So it means whatever you have 3 plus 0 equals to 3. So positive 3 charge will be there on this entity. En is neutral. Whatever you have here, that will be on the coordination entity. So it will decide how many chlorines should be there outside. So there should be 3 chlorines outside. This is the answer. Next one. Amine, bromido, chlorido, nitrito, N platinate. Here it is 8. It means the coordination entity is anionic. And within the coordination entity, we have amine, bromido, chlorido, nitrito, N. Nitrito N means it is NO2 and it is connected to central metal atom through N. Otherwise, we will write ONO. So in the formula, if it is nitrito N, we will write NO2. And if it is nitrite to O, we will write ONO. So how to write it? It is platinate, so it means it will have some negative charge here. How much negative charge we will calculate. Amine means it is NH3. Bromido means it is Br. Remember, NH3 is polyatomic. That's why I have kept it in parenthesis. Br is just one. So I have kept it as it is. Bromido, chlorido, Cl. And then nitrito, N means NO2 in parenthesis. And you have platinate 2. So you will have PT here. And now you should check whether it has 2 here. So how much charge should be there on the coordination entity? Means there are no counter ions given here. So if no counter ions given here, it means it is in ionic form, and it is anion because 8 is there. But how much negative charge is there, you will calculate by platinum has +2 charge, NH3 is neutral, bromine -1, chlorine -1, NO2 -1. So it means total it will be +2 -3 equals to -1. So -1 charge will be there. That is the formula. PT, NH3, Br, Cl, NO2, and on whole coordination entity, 1 negative charge. Next question. In this question, formula is given. You need to write the IUPAC name. It is CONH3O6Cl3. These are counter ions. And remember, you don't write how many counter ions are there. So even if 3 is written here, you will not write trichloride. Okay. Now, first we will name the coordination entity, which is cationic part. So cationic part will always be named first. So we will say here it is hexaamine. So it is hexa, AMMINE. NH3 is written as amine, AMMINE. And then we have cobalt. And we need to see how much charge total will be there. Here 3 minus will be there. It means the coordination entity will have 3 plus charge. And because NH3 is neutral, the entire 3 plus charge will be on cobalt. So we will write cobalt 3. And then we will write the counter ion, which is chloride. But you won't write how many are there. So it is hexaamine, cobalt 3, chloride. Next, CONH3 5 Cl2. Basically, this is an isomer of this one. Formula is same. Only one chlorine is now inside the coordination entity. So similar to that one, now we will say pentaamine, Cl, negative ion. So chlorido. Okay. So if this is in the coordination sphere, coordination entity, we will call it chlorido. Outside, we will call it chloride. So simply it will be pentaamine, then chlorido, and we have cobalt here. Now remember, outside we have -2. So it means on the coordination entity, there should be +2. And if it is +2, and suppose we say the oxidation state of cobalt is X, then NH3 is 0 and chlorine is -1. This whole will be equal to 2 +2, this one. So from here you will get X equals to 3. So again, the oxidation state is 3. And outside you have chloride, so you will just write chloride, not how many. The answer here will be pentaamine, chlorido, cobalt 3, chloride. Next, K3FeCN6. Now remember, this is anionic part. So if it is anionic part, Fe will not be written as iron. It will be written as ferrate, ATE. So not ironate, ferrate. If it is cationic part, then we will write iron 2 or iron 3 depending on the oxidation state. But if it is anionic form, we will write iron as ferrate. So this is potassium. And if this one is named, it will be hexacyanido, or you can write cyano also. Both are acceptable. Cyano is also acceptable. Cyanido is also acceptable. So this will be hexacyanido ferrate, and this will be potassium. And remember, always the cationic part is named first. So you will say potassium, and then you will say hexacyano or cyanido ferrate, and then the oxidation state. Here you have +3, it means on the coordination entity it will be -3. So if iron has oxidation state X, cyanide has oxidation state -1, so it will be -6 equals to -3. So X from here will be +3. So it means you will write ferrate 3. That is the answer. Potassium hexacyano or hexacyanido ferrate 3. Next, K3FeC2O4 whole thrice. Again, this one is anionic, so this will be ferrate. So we will write potassium. And here 3 oxalates, so you will say trioxalato. So it will be trioxalato ferrate. And then the oxidation state of iron, here it is +3, so it will be -3. So if iron oxidation state is X, oxalate has oxidation state -2. So -2 into 3 will be -6. So X minus 6 equals 2 minus 3. So again, X will be +3. So ferrate 3. That's it. So potassium trioxalato ferrate 3. Why oxalato with O? Because this is negative ion, anion, ligand is anion. So that's why it will end with O. Next, K2PdCl4, potassium. Always the cationic part is written first. Now this one, and remember this is anionic part, so palladium will be written as palladate. And you have 4 chlorines, so it will be tetrachlorido palladate. And then the oxidation state. Here you have +2 charge, it means coordination entity will have -2 charge. So it will be X -4 equals to -2. So X will be +2. So it will be potassium tetrachlorido palladate 2. Next, in this case, you have anion, counter ion chlorine. So it means the coordination entity will be cationic. So we will name cation again first. It will be diamine chlorido, and this one is methylamine. So we will write it as diamine 2 amines chlorido, and this one is methyl amine, and platinum will be written as platinum because here it is cationic part. So we will say platinum. With its oxidation state, chlorine, 1 chlorine outside, so it means total 1 positive charge will be there on this coordination entity. If platinum here has oxidation state X, NH3 will have 0, and then chlorine -1, and NH2CH3 again 0, that will be equal to +1. So X will be 1 + 1, that is 2. So it will be 2, and this chlorine outside, so chloride. So it will be diamine chloridomethylamine platinum 2 chloride. Remember here you have CH3NH2, so this is methylamine. CH3NH2 is methylamine. And H3 is amine, AMMINE. RNH2 is amine. So that's why single M here.